Assalamu alaikum students. Today we will be solving 9618 variant 32 of computer science paper 3. The paper code is 9618 variant 32 computer science paper 3, which is advanced theory of the year May June 2023. Okay. So the first question says numbers are stored in a computer using floating point representation. In the question, it has already given told you that there is 10 bits for the mantissa and there is 6 bits for the exponent. There is 6 bits for the exponent. You need to apply the 2's complement from both the mantissa and exponent. Okay, you don't need to apply, but it says in the question. Now, write the normalized floating point representation. The rule which you need to learn is that for a minus negative number, it will always start from 1.0. For a negative number, it will start from 1.0. For a positive number, it will start from 0.1. Number should start from 0.1. Like the decimal place should be placed for 0.1. Now, this number, if you copy it as it is, 0, 1, 0, 1, 0, 1, 0, 0.111. 0, 1, 0, 1, 0, 1, 0, yeah. Now you need to normalize this. If you start this number, you have to shift the decimal place. This is the decimal place. You need to shift it to normalize the number. Normalize means to start from 0.1 or 1.0. So if you normalize it from this decimal point, you shift to the left hand side. So 1, 2, 3, 4, 5, 6. The number is ending on 0.1. You could, some of the students may say that it can also be 1.0. No, it cannot be 1.0 then, because then this 0 will get ignored. Whenever you're normalizing the number, make sure all the numbers come within the range and they are not being ignored. Why? Because you have to keep it in the 10 bits of for the mantissa. So let's enter this number. It will become 0.10101011. Count the number of places: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's your answer. Now, when we talk about the exponent, exponent is basically how much places you're shifting. Left hand side, right hand side, how much places you're being shifting your decimal point. So you shifted 6 places: 1, 2, 3, 4, 5, 6. Now, so your exponent is 6. Now, how are you going to write it down? 1, 2, 4, 8, 16, 32. So 0, 0, 0. 4 plus 2 is 6, and then 0 here. So that's your exponent. And now you copy this number as it is down. So your final answer, and then this will be your mantissa. So 0.101010111. This will be your final answer for 2 marks. 1 mark for the working, 1 mark for the answer. Now, describe the reason why the normalized form of the following binary number cannot be represented accurately. Okay, so they're basically saying that this number, this is of 13 bits. If you count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. These are 13 bits, and they're asking it to represent this 13 bit into these 10 bits of mantissa. So the reason they're saying, why can it not be represented in this bit? The reason, it's obviously very clear, because this number is of 13 bits and this is of 10 bits, so it won't fit in that location. So you have to write a detailed answer for this, and the detailed answer for this, I would show you the points which will make sense. This is the answer, students. It can store only 10 bits. Yeah, because the mantissa is of 10 bits. If you see here, 10 bits for mantissa. So it's related. The questions are related. So it can store only 10 bits. The mantissa of the number would need to be 13 digits. So in order to store this number, you need to add 3 more bits. But then you in the question, you're only given 10 bits. How can you increase more? You cannot increase. And it will cause a loss of precision. Precision means accuracy. So the keyword term you're going to use here is precision, which means accuracy, loss of accuracy. Okay, again, this is chapter 1 question of sequential series and random file access. Describe how records are organized in access in a sequential file. You will need to write 3 points for this. And the 3 points which you need to write are here. If you can have a look. Records are stored in a particular order. Yes. In a sequential file, the records will be stored in a particular order. Why? Because the word itself is telling you that it is in sequence. It is in sequence. So records are accessed one after the other. We all know that records can be found by searching from the beginning of the file. This is for sequential file. How are they organized and how are they accessed? So how do you access them? They can access them by finding the file by searching from the beginning of the file. 3 points for this. You pause the video and write down the points. Hashing algorithm. Hashing algorithm topic. You need to hashing algorithm is used to calculate the storage locations for records in a random file access. The calculate function modulus is 5. So you need to divide it by 5. Each number will be divisible by 5. So the function modulus gives the remainder after integer division. For example, 3003 modulus 5 is equals to 3. So the record key 303 gives the hash value of 3. So 3003 divided by 5 gives the hash value of 3. And 1029 divided by 5 will give you 205, something like that, 205.6. So your hash value will be of 4. Now 7630 divided by 5, it will give a hash value of, divided by 5 will give a hash value of 0. Okay, it will give you a hash value of 0. The next part of the question says several syntax diagrams are shown, okay, from digit 0 till 9. Okay, so 0 till 9 digits are shown, and letters A till Y. So to answer this question, Backus-Naur, this is from the topic Backus-Naur form, translation software, chapter 5. If you read those chapters, if you solve questions, it's really easy. Now, you have been given a variable. It says that two letters are being used. One letter is here and the other letter is being repeated. So two letters are being used with a digit after the letter. First, there are two letters and then a digit is being moved forward. State whether each variable, these are the variable, is valid or invalid and give a reason for your choice in each case. 9SW. Do you think it is valid or it is invalid? I think it is invalid because the variable says that the letter should come first and then the digit. Here, the digit is being written first and then the letters, which is absolutely wrong. So this will be invalid. This will be invalid. Pause the video and kindly check your answers. See, this is invalid. Why? Because the letter, this is the reasoning. You have to give the reasoning as well. This begins with a digit and a variable must begin with the letter. U, W, Y, it is valid. Why? Because I told you the letters, it is in the range U, W, and Y. Yes, it is coming in the range. And a letter will be repeated. So two letters before moving on to the digit. So this is right. This begins with a letter and is followed by two other letters. See, U. This begins with a letter according to the variable rule. It is beginning with a letter and is followed by two other letters. Word contains one or more letters. The name of the variable is one or more letters. Complete the Backus-Naur form for word and use this to complete the BNF for the variable. So for word, what you can write, the answer here is for word, you could say letter, word, and then letter, which means this line indicates that it's being repeated again. For variable, word, digit, and then word again, because digit is being here and this is for variable. Because it says the word contains one or more letters. So one letter here, second one here. One or more means it can be two. One or more means it can be two. Part C says vehicle registrations must begin with two letters and be followed by one, two, or three digits. Always remember, in the question itself, they are giving you the notes. Must begin with two letters followed by one, two, or three digits. Valid letters and digits are shown. Only things which will be accepted should be from this range. Only they are the only valid options. So they're saying state an example of vehicle registration number. Any example with just two letters from here. Take because it's asking you for an example. So just take any two letters from here and take any three digits from here. So if I take an example, I can take it as AC768. Okay. I took AC, you could take MO, whatsoever, any two alphabets, any two letters, sorry, any two letters from this range, ACE, any two from here, and any three digits from here. So this will give you 1 mark. Okay. Draw a syntax diagram for the vehicle registration. You have to explain how you got two letters and three digits in a syntax diagram. Pretty easy. I have already done it. Now I'm going to show you, explain it to you what it actually means. This is the vehicle registration. Okay. So since we had two letters, one letter is here, A, and the second letter C is here. So letter will pass on to the second letter, and then we have three digits. This is the first digit, this is the second digit. The third digit, no, sorry, this is the first digit, this is the second digit, and then this is the third digit. Why? Because after the first digit, the second digit is also being repeated. So since we had three digits, we did not write all three of them in line by line in series. Okay, I made one. This in this arrow is indicating that there is one more digit apart from these two. So this is why we had three digits. This is the vehicle registration syntax diagram. DNF, very easy. 3 marks for this. Please remember to label the boxes. Question number 4. This is from the topic programming paradigm recursion. It's the last topic chapter of P3, paper 3 advanced theory. So all these definitions you have to remember, it comes from the subtopic object oriented programming. Oops. Okay, these are key terms which are used in OOPS. So encapsulation is basically the process of putting data and methods together as a single unit. Getters are methods which are used to return the value of a property. Polymorphism allows methods to be redefined or derived classes, and setters are the methods used to update the value of a property. One will be left, which means nothing, enables the defining of a new class that inherits from a parent class. This answer for this will be inheritance, but it's not given here, so it's not in the answer. Encryption. Encryption is also a topic in chapter 6, security. Encryption is used to scramble data to make it meaningless if it is intercepted. Describe the purpose of quantum cryptography. Quantum cryptography. 2 points. So here I am giving you the 2 points. The first point says it produces quantum cryptography, basically produces a virtual unbreakable encryption system. It protects the security of data transmitted over fiber optic cables. Quantum cryptography basically protects the security of the data which is transmitted over fiber optic cables. Now, in cryptography, in cryptography topic, quantum cryptography, you have two things. One is asymmetric and the other one is symmetric. Asymmetric and symmetric, there are two types of encryption which are used to encrypt and decrypt the data. So you have to explain the differences between both of them. For 3 marks, three differences you need to write. Okay, so I have three differences here. Symmetric encryption uses a single key to encrypt and decrypt, while asymmetric encryption uses two keys. It requires two keys. Symmetric is a simple process that can be carried out. Asymmetric is much more complex process. The length of the keys in symmetric encryption are shorter than those for asymmetric. So in symmetric, you have shorter keys. In symmetric, you have short keys. In asymmetric, you have longer keys. All right, pretty much clear. Let's move forward. Pseudocode questions. Now, do not get scared. In paper 3, you have less pseudocode questions. Basically, this is from the composite data type topic. It's in chapter 1, data representation, composite enumerated data type, where they ask you to write the field names of each data type. So if you read the question, key appointments to hold data about patients for dental clinic, it will include all these fields. And you have to write the data type. What is the type of the data? So this is the answer. So now we will calculate. Type T appointments. The name of the table is T appointments. Declare the name. Yes, we have declared the name as string. Second thing, declare the date of birth as date. This is the second line, date of birth. Yes, we have also done that. Let's tick it. Let's cross check. Declare telephone. Telephone number will be a string because it will be a long number. It won't come under integer or data. Telephone number. It will come under string. Okay, done. Then we have last appointment, date of the last appointment, which will also be of the data type date. Then we have the date of the next appointment, date of the next appointment again. That will also be in the data type of date. All treatments are completed, yes or no. Whenever you have just two answers, we call it as Boolean data type. We call it as Boolean data type. True or false, yes or no, right or wrong. Okay, whatsoever. If it has two options only, then it is known as Boolean. It is known as Boolean. And then you end the type. Okay, so this is completed for this topic. Now, here you have been given some blanks. The next part of the question was saying the pseudocode algorithm reads dental records stored in random file using the user-defined data type T appointments and prints the contents of the file one record at a time. So you have to complete this file handling pseudocode. You have to complete this file handling pseudocode. So first, when you're going to open the file, you will open dental file for records. Dental file for record or basically for random. Okay. And then when you have this line equals to 1 in pseudocode language, this arrow means is equals to, so is equals to 1. So what will be is equals to 1? Obviously count will be is equals to 1. Then when you're seeking the dental file, repeat, seek dental file, count. Here you have to input get the record. You have to input the function get, or just name the parameter get record. Name of the file. What is the name of the file? The name of the file is dental file. Get record from dental file and count the number of records in dental record count. Okay. Count equals is equals to count plus 1 until end of file. EOF means end of file. Until the end of file reaches dental file, then what you have to do is you have to close the file. Close file dental file. Okay, students, pretty easy. Pseudocode, but you have the easier one here. Not it's not like paper 2. Now, question number 7 says that state two examples of where it would be appropriate to use packet switching, circuit switching. Okay, chapter 2. So the answer for that is stored here. It is used for high volume data transmission. Packet switching is used for high volume of data transmission, and it is also used when it is necessary for the communication to be secure. When the communication is needed to be more secure, you use packet switching. And when you need high data transmission, high volume data transmission, you use packet switching. So 2 marks for these points. Now, circuit switching, packet switching are in chapter 2 communication. They're really important. So the four differences between both of them. The four differences between the both of them are here. Circuit switching, I have um, cut down. I have basically made more space. So instead of circuit switching writing the whole word, I wrote CS, and instead of packet switching, I wrote PS. Circuit switching uses a dedicated channel to make communication, whereas packet switching forms data into packets. By the name itself, you can say that it forms data into packets. Data in the packet switching is split into packets, and circuit switching, the message remains intact. All of the transmission in circuit switching follows the same path, whereas in packet switching, different routes for different packets. Circuit switching is simpler process than packet switching. Basic one. 4 points, one point for circuit switching, 1 point for packet switching. Differences between both of them. Okay. So 4 marks you will gain here, students. Okay. Now describe the use of pipelining in RISC. In RISC. Okay, so 2 marks just have to basically describe the pipelining function. Pipelining basically allows several instructions to be processed simultaneously. Simultaneously means two things will happen. If one thing is going in this direction, the other going one is going in the same other direction at the same time. So this is what is meant by simultaneously, which means pipelining allows one, two, three, four functions flowing simultaneously. They're being processed. Each instruction stage is completed during one clock cycle. Now, the processing of instruction is divided into 5 stages. It is divided into 5 stages. Okay. Now, each stage is carried out using different registers when the pipelining is used. Complete the table to show how a program consisting of six instructions would be completed using pipeline. Complete the clock cycle. Very easy. Let's say if I'm taking this as 1.1, 1.2 will be here, 1.3, and 1.4, 1.5, 2.1, 2.2, 2.3, 2.4, 2.5. Okay, this is how it will go. This is the processing stage of pipeline. IF means instruction fetch, ID means instruction decode, I ID means instruction decode. Okay, IF means instruction fetch, OF means operand fetch, and instruction execute, IE is here. Okay, 2.5. Now 3, 3.1, 3.2, 3.3, 3.4, 3.5, 4.1, 4.2, 4.3, 4.4, and 4.5. Okay, 5.1, 5.2, 5.3, 5.4, and 5.5. 6.1, 6.2, 6.3, 6.4, and 6.5. We will stop here at 6.5. Why? Because it only consists of 6 instructions. So 1, 2, 3, 4, 5, 6, 7. Well, 6. Sorry, 1, 2, 3, 4, 6. 6. It starts at 6.1, ends at 6.5. So only 6 instructions. 4 mark for this pipelining clock cycle. Okay, students. The truth table represents a logic circuit. Easy question, logic gate question, chapter 3, logic gates. Now, in logic gates question, one thing you should know that when the output is 1, only when the output is 1, that's when you need to write the Boolean algebra. So we will write here 1, this is 1, this is 1, only when it's on. Okay, so we have to take those readings only. That's it. So we have 4, 5, 6 readings. So let's write it down here. 0 means complement. So A complement, B complement, C complement, and D complement. A complement means 0. D complement, this dash on top of the line represents complement. B complement means 0. Okay, now the output is 1, so this is the first line. The second line will be A complement, B complement, C complement, and just D. Okay, third line will be A complement, B complement, C, and D complement. Fourth line will be AB complement, C and D. Okay. Next one here we have is A complement, B, C, and D complement. Similarly, here we have A complement, B, C, and D. Okay, so we have 6 outcomes, output, and now we have to write all of them together. How will you write them down? Just write all of them together here. 6 of them. The answer. That's the answer. A complement, B complement, C complement, D complement plus A complement, B complement, C complement, D plus A complement, B complement, C and D plus A complement, B complement, C and D, A complement, B complement, C and D, A complement, B, C and D complement plus A complement, B, C, D. Okay, B, C, D. Done, students? Now, complete the Karnaugh map for the given table. Karnaugh map means K map. Karnaugh map map means K map. So you have to complete it, right? You're looking at this. So when you have all these, quantities, let's copy it down there. So when you have all these quantities with you, you can make the Karnaugh map. Okay. How will you make the Karnaugh map? A and B means 0. A and B means 0. So you have to look at the place where A and B 0. C and D will also be 0. All the places where it's 0. So that will be here. You can see A and B both are 0. C and D both are 0. So first one is done. Second one, you have A, B, C 0 and D is 1. So that can be, where will that be kept? AB is 0, C is also 0 and D is 1. So it will be this one. Alright, that's also done. Third one, again A and B is 0, C is 1, but D is 0. It will be this one again. Have a look. A and B 0 0. Okay, A and B is 0 0. C here is 1. You can see in this line C is 1, D is 0. D complement means D is 0. So that is also done. Alright. Now the fourth one is A, B complement, C and D, which is this one. C and D means 1 1. A, B A and A complement, B complement means 0 0. So 0 0 and 1 1. Now that's also done. Now we have just two more. A complement, which means 0. B complement, which means B means 1. C means 1 and D complement. So A complement and B, which is this row. A complement, B is 1. Okay, C complement, C and D complement, which is here. So the answer will be here. That's also done. A complement, B, C, D. Simple. A complement, B, C, D. This one. And the rest of the places you have to write 0. Don't leave the boxes empty. Write 0. This is the Karnaugh map for 2 marks. Really easy. Please understand the topic and do it. If your answer here is wrong, if your answer in this part of the question is wrong, in the start of the question, if it's wrong, then the whole question will go wrong. Draw loops around appropriate groups in the K-map to produce an optimum sum of products. Optimal sum of products. Pretty easy. You need to draw the two. This is the one group, this is the first group. And then this is the second group. Okay, group of 4. Straight here we made group of 4 and here group of 4. Write the Boolean logic expression from your answer to part C as a simplified sum of products. The answer to part C is A B complement 0 0 in the whole line. And here we have A complement and C, because C is 1 1, the same, the common one. So the common one we can take from there is A B complement plus A complement C. Okay, students. Now using the Boolean algebra to give your answer to part D in its simplest form. Now this answer, if you have, it's basically math algebra, Boolean algebra. So doing algebra, you have to answer this question. Pretty simple. Take out the common one outside. A is the common one which will be outside. What is left? B complement plus C. This should be your final answer. All right. Give one category of machine learning. One category, supervised learning. The next question is about AI. Calculate the path that takes the shortest time to travel from begin node to end node. There are very less questions of AI. You'll find it in the 2023, 2022 paper and 2021 paper. Because since AI was added after 2020. Using the A star algorithm. You have to use the A star algorithm. There are two types of algorithm, Dijkstra and A star. You have to use the A star algorithm. You have this graph completed, given to you. This is called graph. You have to do the working. The first one is done for you. So you start node is begin. Your destination node is A. So from begin, you're going towards A. Cost is 5, which is labeled as G. Heuristic value is 8. Okay, so total is you add the G plus H. All the values are given to you. It's already labeled. Now, how will you do it? It's pretty easy. You have to find the shortest path. Okay, so first thing you did is from begin you went to A. Now again from begin you have three ways basically. 1, 2, 3, and basically you have 4 ways. A will go to end like this, B will go to end like this, C will go to end like this, D will go to end like this. So we have to try all of them. Which one is the shortest? We make the path. So start node is begin, destination node is B, cost is 6 and 7 is the heuristic value here. The value on the top of the box is your heuristic value. So 6 plus 7 gives me 13. Again, we begin, but this time we'll begin from C. We're talking about this route. Okay, we're talking about this route. So we have a cost is 5. 5 plus 7 will be 12. Okay. Again, we will begin. And this time we'll begin with D. Because begin and then we're talking about this part. So 4 plus 11. Your cost from here is 4, which is your G. Your H is the heuristic value, which is on top of the box. That's 11. 4 plus 11 is how much? 15. Okay. Now let's talk. Now we have the next option, which is begin. So we'll start from C because we're talking about this one. So C to G. All right. So G, and then the heuristic will be, then the cost will be 5 and 2. This is the one cost. This is the second cost. So 5 plus 2. So 5 plus 2 is 7. You can write it down here. 5 plus 2 is equals to 7. Okay. And the heuristic on G is 5. So we'll count this heuristic value. This heuristic, which is 5. Add 7 plus 5. 7 plus 5 is 12. Okay. The next one is from G to F. G to F. Again, count the cost. 5 plus 2 plus 4. Why? Because since we're counting the cost from begin till wherever it is going. This is one cost 5, this is the second cost 5, and the third one is 4. So we add all them together for this, and the destination is F. You're going towards F, so that's your destination node. So 5 plus 2 is 6, 7, 7 plus 4 is 11, and the heuristic value on F is, always take the heuristic value of the destination node. So it's of 1. So 11 plus 1 is 12 again. Okay. From G, if you take it towards the end, G to end, how much does it cost? 5 plus 2 plus 7, 5 plus 2 plus 7, 5 plus 2 plus 7. This is the cost. How much will it cost? 7 plus 7 is 14. So 14, and your heuristic, so it's 14 here as well. Now let's check from this F to N. F to N. How much does it cost? 5 plus 2 plus 4 plus 1. How much is that? That's 12. And your heuristic value for the end node is, there's no heuristic, so it's always 0. So your answer is 12. Always take the shortest part. Shortest part will be from begin, C to G, G to F, and F to N. This is your shortest path. If you calculate the values from here, it's a random idea. If you start calculating from here, you'll get bigger numbers. Always ASR algorithm means shortest part. So your final path will be begin, then to C, C to G, G to F, and F till N. Pretty easy, 5 marks. Understand the question and do. The pseudocode represents a Q abstract data type ADT abstract data type question with procedures for initialization and to add new error. It is incomplete. At some point, it is incomplete. Study the pseudocode and identify the identifiers to complete this step. Which one do you think is string? An array. It has an array also. An array to store the contents of the queue. Array, where is the array? Where is it? Yeah, here it is. Array. So declare queue of string. This is queue. Points to the last item. Points to the last item of the queue. What is that? Last item is what is that? Rear pointer. Rear means back. Rear pointer. Indicates the number of items. Number of items in the queue is length. That's also an integer. First item, front pointer. So it is already mentioned that it has three integers. In the table, if you can see, it has already mentioned that there are three data types which are of integer. Here also you have three integers, so just front pointer, just read it and answer it. Front pointer. The keyword is here, first item of the queue. Now you have to complete the pseudocode. The front pointer is equals to -1, then the rear pointer will also be is equals to -1. Okay, and then the length will be initialized to 0. Adding a new number to the queue, NQ. The word adding the new number to the queue will be NQ. Okay, NQ. So again, if function, if the length is less than the maximum length, then the rear pointer +1 increment. Then the rear pointer +1. All right. So then if then read the pseudocode, then when the code is coming towards the end, when the rear pointer is equals to 0, if the rear pointer is greater than the max length -1, then the rear pointer will become 0. And if when the queue, the array queue of the rear pointer is being stored in the new item. Is being stored in the new item. So length is equals to length +1. Okay, that's done. Last question of this paper is explain why a queue ADT works better than a stack ADT. Stack and queue both are abstract data type in organizing print jobs. Print jobs. 3 mark. Print jobs are expected. Print jobs are expected to be actioned. To be actioned by the printer in order. They are received. Because in the printer, when you print the paper, it goes queue by queue. The printer queue is a queue. Okay, and the paper in the printer, it prints the paper Q by Q. Third point, if it was stack, the first job the printer received would not be printed. Okay. 3 points why QEDT works better than. So we have to basically write the advantage of Q apps at a time. Print jobs are expected to be actioned by the printer in order they are received. And they're talking about this context. The printer queue is a queue. If the printer was a stack, the first job the printer received would not be printed. That's the